Good morning, good afternoon, good evening. This is the Antrea community meeting. Today is Tuesday, December the 21st, or of course, for those who are living in the United States, it's still Monday, December the 20th. And thanks everyone for joining. And in the agenda for today, we have a presentation from Yang Li about multiple cluster connectivity design. And that's the only topic that we have for today's agenda. So the agenda will be pretty much this presentation and then open discussion. So I would like to thank again you for joining. And now without losing too much time, let's go directly with this presentation. And Yang, please go ahead with your presentation.
Hi everyone. Actually, I have prepared a video for this presentation, and I will show you. Wait a minute. I will share my screen. Can you see the screen I'm sharing?
Yes, I can.
Okay. Here we go.
Hello everyone, my name is Li Yang and I'm from Transfer Technology. Today the technology sharing I bring to you is called the practice of multi-cluster heterogeneous signal communication, which is the practice of using different signals to achieve multi-cluster full match communication. First, I will introduce the network requirements for big data products, and then describe the product requirements for heterogeneous signals. After that, I will explain to you the principles of heterogeneous signals, then introduce some best practice. And last, I will introduce some more practices based on Antrea. You can see the picture on the left. TrustWeb has many big data protection and AI protection to handle many business scenarios. With the development of cloud native, this protection are gradually migrating to our TrustWeb data cloud, which is called TDC. I also participated in the migration, and it's called the communication characteristic of this big data protection. First of all, most of these big data protection are stateful applications, and there is a large amount of point-to-point communication. For example, in the initial process of deep cluster, there are negotiations between several pods of the application. This negotiation depends on the direct communication between pods. For another example, during data migration and backup, you need to find the pod which has the master root from the data cluster, and then copy the data directly with the pod of the master root without using the service load balancer function. And due to some reasons, our customer has deployed several TDC. With the increase of business data and some federation productions, there is also communication between clusters, which required us to provide an efficient cross-cluster communication method. Actually, there are already some cross-cluster communication solutions, such as NodePort, H2 Submariner. But these methods have their own disadvantages, such as the single point of failure of NodePort. H2 and Submariner has the disadvantage of centralized communication. In order to solve this problem, we designed a full mesh network solution for cross-cluster communication. Our TDC was based on Plano for internal communication. So at first, we designed the full mesh communication based on Plano, which means all cluster pods can communicate each other directly without the centralized problem. We can avoid the performance loss. The cross-cluster communication is exactly the same as the internal communication of the cluster. We can achieve efficient communication and meet the needs of big data applications. Of course, this method also has some requirements for the customer environment, such as part one. Worker nodes can communicate directly with each other. Part two, policy idea between clusters cannot be overlapped. Part three, the VI used by Flannel needs to be same. As I mentioned above, for now, the thing I used by TTC is the Flannel. Everyone knows the Flannel is a tiny and pretty thing, which means its main function is to provide network communication, but has no other advanced feature. With the development of business, simple network communication cannot meet the needs of customers. So we need a new CNI to provide more features. We have compared several CNIs, and you can see the differences of them. We have listed some core features, focus on flexible security strategies, network visualization, security encrypted transmission, troubleshooting, and uptime. Look at the form. You can see that Antrea has better advantage in some aspects, such as supporting cross namespace security strategy, supporting wildcard encrypted communication, supporting network traffic visualization and troubleshooting. Basically, all the core functions have been satisfied. Next, let's look at the performance. By comparing the performance data of several CNIs, you can see that Antrea is the top two, especially when compared with the Flannel in TCP mode. Antrea's performance is even slightly higher. So in theory, if the big data application moved from Flannel to Antrea, the network performance will not be decreased. Consider that there would be some UDP services needed in the future. We also compared the bandwidth performance of UDP and found that Antrea's performance is also very high. So from a performance point, Antrea is also preferred. The most important thing is that the new CNI needs to have the expansion capability of heterogeneous CNI communication. On one, some custom TTC won't be upgraded for some reason, but there are some requirements for cross-class communication. So we require the new CNI can communicate with Flannel. Point two, the new CNI also needs to be able to accomplish the cross-class communication like Flannel did. Point three, a big data application may be deployed on other cloud platforms. We don't know what their CNI is, so we also need our CNI to be compatible with other CNIs. So if we want to meet these three features, we need the new CNI have strong scalability. Then Antrea comes. Antrea is a lightweight CNI based on OpenVSwitch, which has strong scalability and can quickly customize the traffic according to our needs. In the end, because of functional diversity, network performance, and scalability, we choose Antrea as the default CNI of our cloud platform. Before we talking about heterogeneous CNI communication, let me introduce the principle of homogeneous CNI communication quickly. As we know, one RPM is host local. Each node has a policy idea. The communication between pods relies on host routes. When communication across nodes, the host route determines the destination of the packet. Point one. Look at the right side first. If the nodes in layer 2 then can communicate in direct connection mode, the route information is completely same. They are all routed directly through the IP of the destination node. This means that if the two cluster nodes are in the layer 2, we can connect the network between them directly by adding the corresponding host routes. And this is also the best performance communication way between clusters. On 2. Next, look at the channel mode. Flannel uses the host route to translate the packet to the VTAP device, and then the VTAP device sends the packet to the destination port. But Antrea is different. Antrea will determine the direction of the target port in the flow type, set the PIP of the channel, and send the packet from the VTAP in the flow type. On the 3, the last one is the wildcard mode, which is also a feature included in Antrea. Its function is currently not supported by Flannel, but after our analysis, the Flannel can also use this function. We only need to install and configure wildcard, and then add some host routes like Antrea did. This picture is corresponding to the 3 types of traffic. On 1, the black line is the direct route mode. In the Antrea environment, the pod packet arrive at the BI first, then send the packet through the gateway port, and then send the packet to another node according to the node route. After reaching the destination node, follow the host route and then send it from the gateway port to the destination port. This is same with Flannel. On 2, the blue line is the channel mode. In Antrea environment, after the packet reaches BI forward through the channel tunnel established by the VTAP device. This is different from Flannel. The red line is the wildcard mode. In the Antrea environment, the pod packet is sent out from the gateway port and then sent to wildcard device according to the root host. The principle is simple. It can also be done for Flannel by adding wildcard devices and corresponding detailed host routes. Finally, this picture is what we want. Through the principal description for the 3 nodes, you can see that for layer 2 direct mode and the wildcard mode, they can be easily connected. But the channel mode is different than the 2 signals. We need to deal with it separately. This picture contains the pipeline related to Antrea, including ARP responder, layer 2 forwarding, layer 3 forwarding, contract setting and matching, service access, and policy for egress and ingress. And we need to pay attention to the flow table related to cross-node communication. On 1, table 20. Here, gateway ARP responder. On 2, table 70. Layer 3 forwarding. Set up a channel tunnel for port forwarding according to the target port CRDR. And we also need to set the correct VI to ensure that it can match the Flannel VI. On 3, table 80. Layer 3 forwarding. Packets will be sent out from the VTAP port. The black part is the flow table for entry-to-entry communication, and the red part is the flow table for entry to Flannel. On 1, in any network communication, ARP packet is sent first. You can see that the action of table 20 is actually exchange the source and the destination MAC address, and the OP field is modified, which makes the packet to be an ARP response. Attention, in the entry-to-entry flow table, the destination MAC address is set to A, B, C, D, E, F, and the peer node will further deal with the global MAC. In the entry to Flannel scenario, Flannel will not process the MAC address, so the destination MAC needs to be sent to the real MAC address of the Flannel type device. Continue to look at the table 70. You can see that the flow table will perform corresponding actions according to the destination CRDR. Set the IP of the destination node as the destination address of each channel tunnel, and set the corresponding VNI at at the same time. The function of reliability is to select the correct port to send the packets. But because of the Antrea friendly scenario, the destination MAC address is not the global MAC address anymore. So we no longer use the original flow table. We need to add a new flow table to match the MAC address of the friend WeTap device. And then the action remains the same to ensure that it will be sent from the WeTap device. The friend side also needs something, for example, adding host root, FTP, and IP information. Okay, this is the principle of the heterogeneous CI. Based on the operation above, the Antrea cluster and the friend cluster can be connected quickly. As we mentioned at the beginning that if the VNI of the two friend clusters are different, they cannot be connected. But based on Antrea scalability, Antrea can communicate with different friend clusters with different VNI, which means it can be used to be a bridge for other cluster communications, just like a relay region. At the same time, if we accomplish the point-to-point communication of heterogeneous CIs, we can use some CodeDS plugin to realize the cross-cluster identification of domain names, such as the Kubernetes AI plugin. After that, we can use headless domain names for cross-cluster point-to-point communication. This will make the cross-cluster communication more convenient. At the same time, because we have shared the differences of CI to connect the network between the clusters, we can customize the service to cross-cluster for some stateless service. For example, point 1. Look at the left side. We create a service in cluster 2, and then we create the same name in cluster 1 by adding its endpoint of this service. Whether we access the service in cluster 1 or cluster 2, the packet will be load balanced to cluster 2's ports. On 2, look at the right side. We can also achieve a service to load balance among multiple clusters without worrying about what the signal is. For example, one cluster 1 and cluster 2 have the same service. The request for the service can be load balanced between clusters. Okay, next is the demo time. The first demo will show you how to connect the network between Antrea clusters. Look at the first cluster. There are 3 nodes. The name of the cluster 1 is test 1, and its IP block is 10.224. And look at the win resources information. You can call them which node. The count of win is 3. All of them belong to the test 1 cluster. Their signal type is Antrea, and contain some more signal information. Look at the host root. You can see that there are some more host root for every node. Also confirm that there are no other host root. Next, look at the second cluster. There are 4 nodes. The name of the cluster is test 2. Port IP block is 10.225, different from cluster 1. Win resource information contains 4 nodes, and the signal type is also Antrea, and also signal information. Also check the host root. Next, we check whether the ports of the 2 clusters can communicate to each other. I have entered into a port by enter command in cluster 1. Also in cluster 2, I enter into the port in the same way. And here is the port IP address. Then we execute ping command between the two ports. You can see all the packets are lost. Next, I will show you how to connect the network between the two clusters. I have prepared a directory in cluster 1. I also have prepared a certification file for cluster 2, which contains certification information and API address. Similarly, we have prepared the same directory in cluster 2 and also prepared the certification file of cluster 1. Okay, next is the show time. Copy the certification file of cluster 2 to the current directory in cluster 1. Copy the certification file of cluster 1 to the directory in cluster 2. Next, look at what happened. In cluster 1, you can see all Win resources, including in cluster 1 and the cluster 2, and also the Win resources. And there are also some more host routes created for cluster 2. Then look at the cluster 2, which also contains all Win resources of cluster 1 and cluster 2. So did the VC resources and host routes. Let's check the port network. You can see that they can communicate to each other as is expected. Let's check the network of host to the port. The communication is fine too. For now, the network of the clusters are completely connected. By the way, let's take a look at some open flow information. You can see that there are some more AIP responder flows created in for cluster 2 in table 20, and IP block related flows in table 70. Essentially, these flows connect the network of the two clusters. Okay, next I will show you how to disconnect the networks. We just remove the certification file from the current directory. Look at the related flows again. They are deleted automatically. VC resources and Win resources are also recovered to the current cluster scope. Pin from the host again no longer works. Pin from the pod again no longer works too. Now the network of two clusters are disconnected. Okay, the first demo is over. Let's see the second one. The second demo will show you how to connect the network between Antrea and the Flannel clusters. Look at the first cluster. There are 4 nodes. Next, look at the host route. You can see that there are some host route for every node, and also confirm that there are no other host route. The name of the cluster 1 is test2, and its IP block is 10.225. There are 3 Win resources. All of them belong to the test2 cluster. The signal type is Antrea and contains some more signal information. Next, look at the second cluster. There are 3 nodes. Also check the host root. The name of the cluster is test3, and its IP block is 10.224, different from test2. When resources information contains 3 nodes, and the signal type is flanner, different from test2. You can see the signal information is all about flanner. Next, we check whether the pods of the 2 clusters can communicate to each other and into a pod by ES ground in cluster 1. And you can see the IP address is 10.225.0.5. Also in cluster 2, I enter into the pod the same way and get its IP address. Then we execute a ping command between the 2 pods. You can see all the packets are lost. Next, I will connect the network between the 2 clusters. Also in cluster 1, we prepared a certification for cluster 2. And in cluster 2, we prepared the certification file of cluster 1. Okay, show time again. Copy the certification file of cluster 2 to the directory in cluster 1. Copy the certificate file of cluster 1 to the directory in cluster 2. Next, look at what happened. In cluster 1, you can see all the REC resources and also the WIN resources, including cluster 1 and cluster 2. In cluster 2, you have the same WIN resources and REC resources created too. Then check the network. The communication is connected. And also the network of the host to the pod. You can see that there are some more ARP responder flows created for cluster 2 in table 20. And IP block related flows in table 70. Different from demo 1, the open flows contain some more information for VNI. Okay, then we disconnect their networks. Remove the certification file. VC resources and WIN resources are also recovered to the current cluster scope. Look at the related flows again. They are deleted automatically. Ping from the host again no longer works. came from the portal again. No longer works too. For now, the network of two clusters are disconnected. Besides the heterogeneous CNI, we have done something more based on Antrea. On the one, with a flexible security strategy provided by Antrea, we designed a zero trust network security architecture based on the network policy and the cluster network policy. Point two, the internal port can get the real source IP of the request from outside, which meets the demand of some audited applications. Point three, with egress function provided by Antrea, we can provide high availability services without any external load balancer. Okay, so the technology sharing is over now. Thanks, everyone.
Hello, everyone. The sharing is over now. Anyone has questions?
Yang, thanks for the great demo and introduction. Sorry, I joined late, and I'm a little curious about what the underlying operation when you move the certificate, the kubeconfig file, why some flow appears and why they disappeared after you remove them.
Oh, it's a little complicated. Let me think about how to. Actually, I have implemented this architecture not in the Antrea, but another project named Vector. There are two components. The first one is the vector controller, which continue to watch the remote cluster, the vector node and vector cluster resources, and get the latest information to the current cluster. And then vector agent sees the new vector node created. Then it will configure some arbitrary open flows to connect their networks.
Basically, you have one component which will import and import resources from other clusters if it has this kubeconfig configuration.
Pardon?
And you have another component, for example, some kind of demo to program the open switch.
Yes, not in Antrea, but in another component.
Okay, so you did it by mounting the OS circuit files to that port.
Yes, our open switch was installed on the host and onto the socket file to Antrea and my another component.
Okay, thank you. Got it.
Hello, thanks a lot for this presentation, Yang. It's been very informative. I'm just curious about what is the mechanism for updating the cluster routes when nodes are dynamically added or removed to clusters?
Hi, Vicky, can you help me to translate?
Chan, Vicky, can you help me? My Chinese is not good enough.
I can hear you. Yeah. 它就是说，在这个 cluster 里面有一个 node， 比如说被临时的移除或者是加入，然后你们是怎么解决这个问题？比如说 Antrea to Antrea 或者 Antrea to final， 这个某一个 cluster 内部有一些动态的 node 的改变， 比如说加进来一个或删除一个，你们是怎么适配的？
I see. We just remove the vector node results. Then the remote cluster watch the delete event of the vector node, and then the vector agent will delete the related configuration. Okay.
Thanks. And I have another question. In terms of scale, what kind of scale have you tested at the moment? I'm sorry, but I have to ask in English because what are you, but I how?
Yes, I think just you say 不太好. Yeah, it is good enough. Yeah, Yang, I just think just now you show us the recording. I know it is a recording, but I can see the picture. Yeah, it's not clear. I think if you can show the PPT, I think it should be much clearer than just now. I'm not sure whether it is just my problem, but I can see, yeah, the PPT is not clear in the recording. So I think you can give us the PPT as well. Maybe we can just yeah, share with the team.
Okay. I will now. I will sharing the PPT for wait for a second. Is that clear?
Oh yeah, currently it is clear. I think you can just highlight some pages. Seems like you I know you changed a little bit for the existing Antrea open flow tables. I think you just yeah. Yes.
This picture.
Yeah. Do you want to repeat something about the three tables? I know you changed a little bit for the three existing tables.
Oh, okay. I will introduce some information about this flow table. The black table is the for entry to entry. You can the table 20. We know that it's about the ARB responder for the beer gateway. And in entry to entry mode, the source MAC address will be modified to a global MAC address, but in entry to Flannel scenario, the source MAC address will be modified to the Flannel with type devices, because the Flannel cannot deal with the global MAC address. And for table 70, it's similar to the entry to entry flow table, but the difference is there will be when I set up, you see the last word, there will be some when I set. And for table 80, as we know, we use the global MAC address to match the to send the packet to the destination node. But for entry to Flannel scenario, the destination MAC address is set to be the Flannel with type device, so we cannot use the original flow table. So we add a new table in table, a new flow to in table 80 to match the Flannel with type device, then send the packet to the remote node. And in the Flannel side, we also need to do something just like Flannel to Flannel did. For example, you add some host routes and add some FTP and ARP information. Okay, this is the introduction for. Okay.
Yeah, I think just now maybe Quan missed this part. So Quan, I think it is a key point about this new implementation.
Yeah,
Yes.
got it. Thank you.
Hi, Yang. I have a question about the implementation. When you mentioned about the third party to the vector or something like that, I'm not sure the name. Maybe you can type it on the chat window. Does it mean you have no change on the existing entry, right?
Yes, I added another accompaniment to add these flows, and I will make sure the cookie won't conflict with Antrea. So if
Okay.
Okay, so if the entry engine restart, the cookie may be changed, increased. So I set a large cookie for my component.
Oh, okay. So there's some special for the cookie.
Yes.
Okay, you just mentioned about the node agent restart. So when the agent is restarted, your vector agent will also watch the event, right? Or
For now, it haven't watching the entry engine event, but in the future, maybe it will be considered.
okay, thanks.
Okay, any questions?
Is there any other question for Yang?
Oh, I have also Tianjian, what's the largest scale you have tested with the solution? Actually, not too large. It's not deployed in the customer environment for now. Perhaps in next year it will be tested.
Thanks.
Yeah, Yang, I have another question. Just now you mentioned you didn't choose Submarina because it has centralized gateway to support the connectivity. So did you make some benchmark test to understand the difference between the full mesh and the centralized gateway solution? Do you think the performance gap is big?
I haven't tested, but actually I have met some similar problem in the because the big data translation will cost too much bandwidth. That in theory, the centralized translation will be limited for our big data production.
Okay. So I'm not sure in the big data use cases, maybe later, do you consider to implement something like a service global discovery, global service discovery or stretched network policy in your scenario?
I have designed such services, but for now, we haven't get some requirement for this service because our company, most of the data is set for production.
Yeah, so I understand your scenario is only focusing on the pod to pod connectivity, right? Across different clusters.
Yes.
So you don't need any service or network policy.
Yes.
Okay. Thank you, Yang.
Oh, you're welcome. So, any question?
Any more question for Jan? All right, I believe that maybe it's all for today. I would like to thank you for this presentation. It's been very informative, and it's awesome what you can build for what you have been able to build with Antrea. So thanks a lot for sharing this with our team, with the Antrea team, and thanks a lot for contributing to the Antrea. Yep. Is there any more point? Any more question? Any other thing that you would like to bring up for today? I'll wait a few more seconds. And it seems that is all for today. So I would like to thank Yang again for his presentation. Thanks everyone for joining, for being with us today. This is our last community meeting of 2021. So I would like to wish everyone a happy ending of this year and a great start to the new year. And we'll talk again in 2022.
Thank you. Bye.
Thank you.
Thanks. Bye-bye.
Thank you.
Bye.
Thank you. Bye bye.
Yeah.
You're welcome.